All right, ladies and gentlemen, this video is going to be about more ways to factor and factoring some more complex expressions. And remember, to factor is just to unmultiply, to break it down into its multiplication parts. This first example is just another way to factor quadratics. If you've been able to factor quadratics like this, we did this in our quadratics unit. But there are options. I just want to give you another option that maybe is, if you like procedure and you like step 1, 2, 3, 4, 5, this might be one you like. This one's called slide and divide. So what I'm going to do is I'm going to take this 18, slide it over, and multiply it by 10, which leaves me with x squared plus 27x plus 180. And now, with the 18 gone from the front, I have created just a 1x squared. Now I'm going to factor this as if I would factor it if that was the original question. It's not the original problem. I've changed it, but we're going to change back in a minute. But the good part now is that I have a 1 out front, which allows me to factor x and x. And now I just need the two factors of 180 that add up to 27. So 180 is, it's 3 times 60, it's 10 times 18, it is, what is 180? I need the two factors of 180 that make 27. And those two factors are 12 and 15. Okay, so I slide the 18 over, I factor the quadratic that I get after I multiply 18 by 10. This is all these other methods, the AC method, the box method, you might have learned one. They're all really the same thing. They're just presented in a different order of steps. Anyway, the 18 that I slid over to divide by 10, or to multiply by 10, I'm going to put that underneath each of those. Now, if you create fractions that can be simplified, simplify them. 12 eighteenths, 6 goes into 12, and 6 goes into 18, that's 2/3. And 15 eighteenths, we're going to divide, let's see, that's going to be divide by 3, 5 over 6. And it really should be called slide, divide, and slide, because if you end up with a denominator after you simplify that fraction, I'm going to slide that denominator back out to the front and get 3x plus 2 and 6x plus 5. So you slide the A, the 18 over, and multiply it by C. You factor with a 1 in front. Put the 18 under the two numbers, simplify, and slide back. And you can check this, multiply that back out, and make sure that's going to give us a 27x in the middle. So that's just another way to factor a quadratic. So there's example 1. Next, so far you should know that you can factor a difference of squares. We can factor x squared minus y squared and get x plus y, x minus y. If the powers are odd, and we're just going to do cubes today, but with 5, 7, 9, etc., you can do a sum or a difference. So we're going to do sum and difference of cubes. And these are two formulas. If you were to multiply this out, you can see why it would work. You know, just take that and multiply it through here. And you'll see how everything cancels out except x cubed and y cubed. I'm not going to do all that for the sake of time, but if you multiply that out, you'll see everything disappear except x cubed plus y cubed. Now, this example that I've given you, it doesn't look like a sum of cubes, but I did that to reiterate a point. When you factor, the first thing you should do, regardless of the strategy you're using to factor, regardless of what kind of expression you're trying to factor, you should try to get common terms out first. Factor out the greatest common factor. So what goes into both 24x to the 4 and 81x? 3x. When I factor that out, when I undistribute 3x, I'm left with 8x cubed plus 27. All right, when I divide both of those terms by 3x. Now what I'm left with is a sum of cubes. I'm left with 3x here. This is 2x cubed, right? 2 cubed is 8, and 27 is 3 cubed. I don't need all those parentheses, but I just wanted to write them as cubes. So what we can tell now is there's a 3x in the front. When you factor that out, don't lose it. Don't leave it off your final answer. But this sum of two cubes is going to factor where, quote, my x from the formula above is actually 2x, and my y is a 3. So my first term is x plus y. So that's 2x plus 3. And then x squared, which is going to be 4x squared, minus xy, so that's minus 6x plus y squared, which is plus 9. And these two things are equivalent. Remember, when you factor, you're not changing anything. You're just breaking it down into parts, which means you can always check your answer. Just multiply it back together. We've been talking about multiplying polynomials out, so multiply this out, including the 3x, and make sure you get back to your original answer, and you'll know that it's correct. It's kind of like when you solve an equation. Plug in the answer to know 100% certain that you got the answer right. That will work for difference. You can see the difference in the formulas. If we start with a minus here, we have a minus here, and then two pluses. If you start with a plus, plus here, minus here. And that's just due to the nature of the terms that cancel each other out. Okay, so let's go on to our next example. Hidden difference of squares. This is just a little, not a common topic, but there's a section in your book, and they're kind of neat, so I thought we'd talk about this as well. This is actually a difference of squares, but you don't have to complete the square, but you have to recognize the completed square. All of this is a completed square. In previous sections in our quadratic unit, we would have added the constants to complete that square, but it's already been done for us here. So this is p minus 7 quantity squared. Okay, because if you were to multiply p minus 7 out, you would get the quadratic that I started with. Minus 9k squared, or to write it as a difference of squares, 3k quantity squared. Once you recognize, then it's easy. Then it's a plus b, a minus b. So a plus b would be p minus 7 plus 3k. A minus b would be p minus 7 minus 3k. So that's a way to factor that one. I call it a hidden difference of squares. Our book calls it a harder difference of squares, but get the idea. You just recognize it as a perfect square, and then you can factor it. All right, quadratic form. This is different because we have a fourth power and a square, and then a constant. What I want you to know about this is it's exactly the same as factoring a quadratic. It's just that you're going to have an x squared in the first two slots rather than just an x in the left-hand part of both sets of parentheses. If you want to know why that works, just let y equal x squared. If y equals x squared, then what we have is 9y squared minus 56y plus 12. And we can factor that with that simple substitution. And you can see that we can factor it just like a quadratic. You don't have to sub out and use another letter like y. If you want to, if it makes you more comfortable, you can. Or you can just realize that, hey, instead of writing an x, I'm going to write an x squared. Just for practice, I'm going to do this one with slide and divide. So I'm not going to use the y. I'm going to come over here and start over. If you would like to sub out and use y, like I said, feel free. But just make sure you sub back in just a minute. I'm going to use slide and divide. I'm going to slide my 9 over and do 9 times 12, which is, let's see, that's 90 and 18, that's 108. Now I need two factors of 108 that add up to negative 56. I'm going to have to pause and search for those. Well, those are easier to find than I thought they were going to be. They are negative 54 and negative 2. Okay, so I slide the 9 times the 12. I'm going to divide both of those by 108 and simplify if I can. Excuse me, scratch that. I'm going to divide both of those by the 9 that I slid over originally and simplify them if I can. Remember, these x squareds were x's in the problems we used to do. Now they're x squareds. It doesn't matter. No big deal. So this first one becomes x squared minus 6. And the second one becomes x squared minus 2/9 because 2/9 won't simplify. So the first one, if you don't have anything to slide back out front, you just don't slide anything back out front. The second one, 9x squared minus 2. So I should set a good example and check, and not just tell you to check. So if I'm checking this, what I'm going to do is I'm going to FOIL it out. I'm going to do first outer inner last. 9x squared times x squared is 9x to the 4. X squared times negative 2, negative 2x squared. Negative 54x squared from the inner terms plus 12. Middle two go together to give me negative 56x squared. And I have 9x to the 4 minus 56x squared plus 12, which is what I intended to break down. All right, so that one practices the slide and divide, and it also shows if you have powers of 4, 2, and 0 instead of 2, 1, and 0, no big deal. Just instead of writing x's, you're going to write x squareds. All right, so that's our discussion for today on different types of factoring. Just to review quickly, we've got our slide and divide. All right, this is not something you have to know how to do. If you would rather guess and check by breaking up the 18 and breaking up the 10 into all different combinations until you find the one that works, that's fine. If you know another method, AC method, or split the middle term, or whatever you want to call it, that's fine, but this is just another option. Sum and difference of cubes. All right, with squares, it has to be only a difference. You can't do a sum of squares, but with cubes, you can do both. Hidden difference of squares, finding that completed square and going from there. And then in the form of a quadratic just means you could have x squared squared, which would show up as x to the 4th, x squared in the middle, x to the 0 at the end. So that wraps it up. I have enjoyed factoring with you today. I hope you have too. Have a lovely day. Young out.